Hi, guys. Hi, ladies. Hi, everyone. It's Pryia again. I know I said that Amy might be back this week, but I didn't guarantee that she would be back. So hopefully you guys aren't too upset. If you guys are upset, I apologize, but you're stuck with me today. So there's no way out of it. It is Math Wednesdays with a Learning Liaison, and I am your guest star, Pryia. So, like always, let's get mathing. Question 1, I'm going to get better at this, is a trigonometry question. It is middle or high school level, something that we see often. So let's go ahead and read it out. A tree casts a shadow that is 35.6 feet long. Okay, that seems pretty important. Let's highlight it. And at that time, the angle of elevation of the sun is 55 degrees. And they want to know what is the height of the tree? Well, I always say it, and I'm a strong believer of it, draw it to see it, and then do the math behind it. So let's draw what we know. Here is my tree. Let's say that my sun is over here, right? So what is going on? My tree is 35.6 feet, and what does it do? The sun casts a shadow, and the angle of elevation from that is 55 degrees. So what does that look like? Oh, the shadow is 35.6 feet long. You guys are probably screaming at me and I can't even hear you. The shadow, 35.6 feet long. Okay, so that elevation will be over here at 55 degrees. Okay, now that you stopped yelling at me and I have everything in the right spot, let's go ahead and solve the problem. So what do I see? They want to know the height of the tree, which is over here, which we're going to name as X. Does this look familiar? Does anything come to mind? When I say Sokotoa, you should say, oh yeah. So we have to figure out which one of these we're going to use. Well, I have my 55 degrees here. I want to find the opposite number of it, and I have the adjacent number. My hypotenuse is missing. Opposite and adjacent will give us tangent, so let's use tangent. So tangent of what? Tangent of 55 is equal to what? The opposite, which is X, over the adjacent, which is 35.6. Okay, well, we want to solve for X by itself. So our function is currently being divided. So we need to do the opposite operation and multiply both sides by 35.6. So they're being divided, multiply. Let's see what we get. 35.6 times tangent of 55 will give us our X value that we're looking for. And it just so happens to be that X is equal to 50.84 feet. Oh, winner, winner, chicken dinner. D for David. Okay. Let's go to question 2. Question 2 is a geometry problem that can often be seen in middle or high school level math. So let's read the question and go through it. You are organizing a closet and want to put 2 smaller boxes into a larger box. Okay, so they're telling me how many boxes I'll have, so let's look out for them. They tell you that the first box measures 2 inches by 4 inches by ½ inch, and the second box measures 3 inches by 6 inches by 2 inches, and they tell you what? The larger box measures 2 feet by 3 feet by 1 feet, and they want to know, will the smaller boxes fit into the larger box? I don't know. Do you know? Well, we have to figure out how large the boxes are. In order to figure out how large a box is, we need to solve for its volume. Volume is not always found on your formula sheet. So these are little things that you need to make sure that you know because they're not going to tell you it. Well, I know that the volume of a box or a cube or a rectangular prism is going to be length times width times height. I'm now going to solve for the volume of all three of my boxes and figure out what I need to do after I do that. So let's start with box 1. So box 1 is 2 inches by 4 inches by ½ inch. Box 2 is 3 inches by 6 inches by 2 inches. And box 3 is 2 feet by 3 feet by 1 feet. Okay, there's a red flag there. Not all of the measurements are the same. So let's glance at our answer choices to give us some guidance on where we need to go based on measurement. Well, A is talking about cubic inches. B is also talking about cubic inches. C talks about cubic inches, and so does D. So what do we need to do? We need to put everything in inches before we can solve. Well, box 1 and 2 are fine. Box 3 will need to change. Once we solve, we'll be able to find what we're looking for. If you didn't know that you needed to do volume, your other hint was in your answer choices, cubic tells you that it's going to be volume. Squared tells you that it's going to be area. Okay, so our answer choices really help us out a lot in this one. So let's start solving. I know I keep saying that I'm going to, but I'm going to do it this time. So let's do box 1. For box 1, my length is 2 inches. I'm going to multiply that by 4 inches and multiply that by ½ inch. And I happen to get 4 inches cubed. Box 2 is 3 inches by 6 inches by 2 inches, which gives me 36 inches cubed, or cubed inches. Okay, well, remember we said that we had to change our measurements for box 3 in order to solve. So we have to know about feet and inches. I know that 1 foot is 12 inches. I'm going to use that to solve for a proportion in order to solve for my problem. So I'm going to take each of the measurements and do a proportion to solve. My first measurement is 2 feet, and I'm looking for the amount of inches. Well, I'm going to multiply 12 by 2 to get 24 inches. I can multiply each number by 12 now instead of guessing, is it division or is it multiplication, to solve for the problem. So I have 36 and 12. These are all inches, which I started with 2 feet by 3 feet by 1 foot. Okay, so when I multiply those nice large numbers, 24 times 36 times 12 will give me 10,368 inches cubed. Okay, well, I have the sizes of all of my boxes, and my answer choices, when I glanced at them earlier, I noticed that they were telling me about space. So how much space do I have left based on what I already have? So if I add my first 2 boxes together, 36 plus 4, I'll get what? I'll get 40 inches cubed. When I now subtract that, because that's how much space they're taking up in the big box, when I subtract that from the big box, I get what? 10,328 inches cubed, or cubic inches left over. So I know that I have space left over, and our answer that we like here is going to be D. Winner, winner, chicken dinner. Yes, and you have 10,328 cubic inches left over in the box. Okay, here we have a measurement problem. Middle, elementary, or high can be seen almost anywhere. It's a basic measurement problem. So let's try it. it tells us what? There are 4 bunches of bananas that weigh 3¼ pounds each. Then what do they tell us? And 2 packs of strawberries weighing 12 ounces each. What do they want to know? How much does the fruit weigh? Okay, but they didn't give me anything to work with. I'm going to look at my answer choices to help guide me to where I need to go. I see that all of my answers are in pounds. So that means I need to convert everything into pounds in order to be successful in the problem. Well, let's start with our bananas. What do I know about them? I know that I have 4 bunches of them, and each bunch is 3¼ pounds. Well, it's already in pounds, so I don't need to do anything with it. You can take 3¼ and plug it into your calculator. You can convert it into an improper fraction. You can do anything with it at this point. I'm going to change it into an improper fraction, multiply, get an answer. It will all give you 52/4. My improper fraction here would be 4 times 3 is 12, plus 1 is 13/4. 13 times 4 over 13/4 times 4/1 will give you 52/4. That, in turn, will actually give me 13 pounds even. Those are my bananas. Okay, now what do I know about my strawberries? I know that I had 2 packs of them, but they're at 12 ounces. They're not in pounds. So I have 2 options here. I can figure out my total ounces first and then convert, or convert and then figure out my total. I like to figure out my total and then convert. So I know that 2 times 12 is 24, so I have 24 ounces. Now the question is, what do we know about ounces and pounds? I know that 1 pound is 16 ounces, and I'm going to put what I now need to solve for, the amount of pounds over 24 ounces. When you cross multiply, you'll get 16x is equal to 24. Divide both sides by 16, and x is equal to what? 1.5, or 1.5. Okay, well, now that this is my pounds, and I know that those are also my pounds, I'm going to put them together to get my total. So I'm going to have 13 pounds plus 1.5 pounds to get 14.5 pounds, which is the same as saying A, 14.5 pounds. Winner, winner, chicken dinner. All right, you guys know how I feel about the higher level questions. Here is a calculus problem. It's from high school or college level, and it's not as bad as you may think it is. So we look at it and go, what do we know? Well, I know that I'm going to have to use a rule. Why do I know that? Because I have 2 things that are being multiplied together. So off the bat, I'm going to write out my product rule. My product rule states that d of dx of the function will give me f of x multiplied by the derivative of g of x added to g of x times the derivative of f of x. Okay, but how do I know which one's which? You just give the first one f of x, and you give the second guy g of x, and then you work from there. So my f of x in this case is going to equal the square root of x, and my g of x in this case is going to equal ln of x. Okay, well, I like to take my derivative and then plug them in back to the rule. So let's take the derivative of the square root of x. Well, first, before I take the derivative, I'm going to rewrite my function. Why am I going to do that? Because I'm going to get x to the half power. It's the same as the square root of x. So now I'm going to take my derivative. I'm going to take my exponent and put it in the front, and I'm going to subtract 1 from my exponent. So I'll have half x to the negative half power. Now I'm going to do the same derivative, not the same derivative, but I'm going to take the derivative of g of x. There is a lovely rule that tells us the derivative of ln of x is 1 over x. Okay, now I have what I need. I'm going to plug it back in and get an answer. Here we go. So this is going to be equal to f of x, which is x to the half power, multiplied by the derivative of g of x. So I'm going to multiply that by 1 over x. And then I'm going to add, what am I adding? I'm adding g of x, which is ln of x, multiplied by the derivative of f of x. 1/2 x to the negative half power. Okay, doesn't seem too bad. Now, we've got some fractions, we're being multiplied, we don't let it bother us. Here, what do we end up with? Well, remember, the x to the half power is all over 1. When you multiply two fractions, what happens? You multiply the numerator, multiply the denominator. Here, we will get x to the half over x. Well, now what happens to the other side? That negative half actually tells us that we can take that guy and put him in the denominator. There's a property for that. So I will add ln of x all over 2x to the half. Well, where did the 2 come from? It's the 1/2 power. The same as saying ln of x all over x to the half times the half. Right? Because everything is being multiplied, I can manipulate it how I need to see what I need to, where I need to be. Okay, well, I've gotten pretty far, but we have to ask ourselves, is there anything that we can reduce? Well, off the bat, the only answer choice that gives me something that has anything to do with what I just found is B. That is our winner, winner, chicken dinner. But before we move forward, let's talk about how we get that 1 over x to the half. Well, when I have variables that are being divided that are the same, I subtract my exponents. So here I'll have half minus 1 to give me a negative half. Remember, we talked about negatives being able to be put in the denominator to become positive. So when you rewrite it, you will get 1 over x to the half plus ln of x all over 2x to the half. You could find a common denominator, but it's all dependent on what they're looking for based on your answer choices. So remember, winner, winner, chicken dinner, B. All right, let's go to number 5. Number 5 is an algebra problem. Oops. It is an algebra problem that is a middle or high school level. So members of a landscaping company built a retaining wall. They used brick to make the top 2/3 of the wall brick. The wall is 8.5 feet long and 2 3/4 feet high. They want to know the area of the brick portion of the wall. Well, what is information that we need? 2/3 of the top of the wall is brick. We need to know that the wall's length is 8.5 feet and the height is 2 3/4 feet. They're asking us for what? The area of the brick portion of the wall. So I always say that it's best to draw and then figure out what's going on. So if I had to draw this, here is my wall. The top half, well, not half, the top third is going to be made of brick, and the bottom is going to be made of whatever it is. What do I know about the entire wall? The entire wall is 2 3/4 feet high, and it's 8.5 feet long. Well, I have to figure out how large the brick portion is of that wall. I only need to know 2/3 of the actual wall. So what is 2/3 of 2 3/4 feet? Well, I gave you a hint on how to solve. We're going to do 2/3 of 2 3/4 feet. Okay, there's a nicer way to write it. So what we're going to do is rewrite our 2 3/4 feet as an improper number. So 2 times 4 is 8, and 8 plus 3 is 11 over 4. That makes it easier for me to multiply, or you can put it in your calculator. So 2 times 11 is equal to 22, and 3 times 4 is 12. Well, I can now rewrite that as a mixed number instead of leaving it like that, or I can just leave it like that. Let's see what happens when we leave it like that. Well, that's not our answer. We haven't figured out the area of anything. We've only figured out how high that brick portion is. So this number represents the height of the brick portion. That is 2/3 of whatever the total height is of the wall. Okay, now the area of this wall is what? Well, the area we're looking for, they didn't tell us the shape, we're going to assume that it's rectangular, is the length times the width. So plug in what we know. Area equals the length, which is 8.5 feet by 22 over 12. A lot of you hate fractions and you're cringing right now, but fractions didn't do anything to you. So let's go ahead and change our 8.5 into an improper number. 8 times 2 is 16 plus 1 is 17 over 2. Okay, now I'm going to multiply. I'm going to get a nice large number. 22 times 17 is going to give me 374, and 2 times 12 is going to give me 24. Well, 24 goes into 374 15 times without going over, which happens to be D. Winner, winner, chicken dinner. But let's keep going. Okay, well, 15 times 374 actually gives me a 360. So when you subtract that from the numerator, you get how much you're left over with. So you'll have 14 over 24 left over. That just so happens to be reducible by 2 in the numerator and the denominator to give us 15 and 7 over 12. It's always good to check your answer choices just in case only one of them has the number you're looking for, so you don't have to do the extra work. I always do the extra work because you're here to watch me do math. Okay, let's keep going. Number 6. Here's a number sense problem. Our number sense problem can be seen in elementary, middle, or high school. It's understanding numbers. So I've actually figured out that, well, I didn't figure it out, but there are 2 ways to solve this problem. So we're going to split the screen in half, not really half, but I'm going to split the screen. So then I can do it one way and then have room to do it another way. Okay, so the first way that we can tackle this problem is taking our fractions and turning them into decimals. It's a simple calculator portion, right? And if you don't have a calculator, you're probably going to want to do it the next way that I'm going to do it. So people with calculators on your exam, here we go. We're going to type in 4, then press the negative sign, not the subtraction sign, and then divide by 7 and get what? We will get negative 0.5714. I like 4 decimal places. Now we're going to do the next side. 5 negative divided by 8, and that will give us what? Negative 0.625. Okay, well now I have to figure out which sign, A, B, C, or D, will go into the box for the missing portion. Well, it's definitely not equal to, and I have to figure out which one is larger. Well, staring at the numbers isn't going to help me. The best thing I can do is to say, let me put it on a number line. Here is positive 1, 0, negative 1. Okay, well, negative 0.5, that sounds like it's really close to half. So that's going to go over here. Well, 0.6 is closer to negative 1, so that's going to go next to it. Well, remember, with negative numbers, it's the number closer to 0 is larger. Actually, the opposite of positive numbers. So in this case, negative 4/7 is larger than negative 5/8. So our winner chicken dinner is B, because the alligator loves to eat the larger number. Okay, you don't have a calculator, and you are not going to sit there and actually do 7 divided by 4. How many times does 7 go into 4? How many times does 8 go into 5? You want another way that's quick, still simple, but gives you the correct answer. Okay, so we don't have a calculator, no problem. I'm going to do what my elementary schoolers call the butterfly method. And if that doesn't ring a bell, I'm going to draw it out and then do the problem. So here, I'm going to try to draw a butterfly. Please bear with me as my Picasso skills are not so great. Okay, do we kind of see the butterfly? I put some antennas on my butterfly here. We have a butterfly. So I'm going to do the butterfly method. What does the butterfly method say? It says that if I take 8 and multiply it by negative 4, I take that number and put it above the negative 4. I then do the denominator 7 and multiply it by my numerator negative 5 and put it on that side where the negative 5 is. I can compare those two numbers. So 8 times 4 gives us what? 32, and 4 is negative, so negative 32. Now 7 times 5 is what? 35, and 5 is negative, so negative 35. Okay, so now I'm comparing negative 32 and negative 35. Remember, the closer you are to 0, so the less debt you have, the larger you are numerically. So who goes in the middle? Negative 32 is larger than negative 35. It's the same answer choice. So if you don't have a calculator, I would suggest using the butterfly method. If you have a calculator and decimals confuse you because you don't like negative numbers, then I say use the butterfly method. If none of the above confuses you, go the regular route. All right. Number 7. It is an algebra problem, and our algebra problem is elementary, middle, or high school level. So it says Wilson is learning algebraic properties and is starting to confuse the commutative property and the associative property. That seems like some important information. So let's help Wilson identify the correct usage of the commutative property. So first we need to know what our properties look like. Well, I'm going to write out the commutative property and the associative property based on addition and multiplication because that's kind of all that I see in my answer choices. So if I write them out, then I can see what's going on. If I can see what's going on, then I can compare that to my answer choices and I can get myself an answer. So let's start. What do we know about the commutative property? What do we know about the associative property? So for the commutative property, I can move around my community freely. So it's like being in a community. Why do I say that? Because remember, we can move around how we want. So if I have A plus B plus C, I can move things around however I want. I can have C plus A plus B, or B plus C plus A, anything other than the original order. And for multiplication, if I have A times B times C, I'll in turn have anything other than the original order, B times A times C. Okay, so what do I know about the associative property? Well, the associative property reminds me of being associated with a group. Why do I say associate with a group? Because it's like regrouping yourself. Okay, so the regrouping here is used loosely. So regrouping does not mean take from one to put to the other. It's just how you arrange yourself, the group that you're with. So I'm going to use that term loosely. So what do I mean by that? I mean that if I have A plus B plus C, so you see how we have a group of A and B, I can regroup by saying A plus B plus C. Now I have a group of B and C. And the same for multiplication. A times B is being grouped together times C. So we have a group again of A and B, or we can have a group of B and C, and then you do another group on the other side. So now we have B and C. Okay, so now that I know my properties and I know what they associate with, let's try to identify what we have A, B, C, and D. So A says A plus B plus C is equal to a group of A plus B plus C. Well, that doesn't really look like either properties, kind of like part of one and a part of the other. That's actually just a regular addition. It's not either properties. A is not what we're looking for. Okay, well, B says A times B times C is equal to C times A times B. Remember, we can move around the community however we please. So B is definitely what we're looking for. But let's look at what else we have. C says A is equal to A. Well, that sounds like a property that says the same thing. It's like mirroring something. It's called the reflexive property. And D is telling me A times B plus C is equal to AB plus AC. That also sounds like a property that I know, and it's called the distributive property. So C and D are also not what we're looking for. The only answer here that we like is B. Winner, winner, chicken dinner. Okay, number 8. Number 8 is a statistics or probability problem that can be found in middle or high school. So it says what? A street magician is performing a new trick, and the new trick has what? It has a red cup, a blue cup, and a yellow cup. And if he lines the cups up on the table in front of him, they ask us our question. What is the probability that the yellow and blue cup will be next to each other? Well, I can't really plug this one in to a formula because why? Because the formula is not going to tell us the actual outcome. It's just going to give us numbers. But we don't want numbers. We want actual combinations of what we have to do and what we see. Well, if I have a red cup, a blue cup, and a yellow cup, he's telling us to line up our cups on the table, and they want to know how many different ways we can do that, but remembering something, remembering that the yellow and the blue are next to each other. So I know that I can start with a red cup, have a blue cup, and then have a yellow cup. Well, I can start with a red cup again, and I can then have a yellow cup and a blue cup. Well, I can't start with red again because there's no other way to write any of the combinations out without repeating what I already have. So I move on to a different color. Let's do blue. So now I'll have a blue cup, a red cup, and then a yellow cup. I can do blue again, a blue cup, this time a yellow cup, and then a red cup. Okay, well, I can't do blue anymore, just like I ran out of options for the red one. So the only guy left to start with is the yellow cup. Then we'll have a red cup and a blue cup. Start again with the yellow, blue, and then red. Okay, I've done all my combinations. There's nothing else that we can possibly do without repeating what we already have. So what was that stuff that we were supposed to remember? We want to see where the yellow and the blue cup are next to each other. So here is a yellow and a blue. Oops. Here is a yellow and a blue. They didn't say it had to be yellow and blue in that particular order. That's key here. So I can do yellow, blue, or blue, yellow. Either or, it doesn't matter. If they were specific, that would change our answer. And we can do that one after we finish this problem. So here's a blue and yellow, and here's a yellow and blue, as long as they're next to each other. So all of my answer choices are in what? They're in fractions. What do I know about fractions? I know that the top number is the number I'm looking for or solving for. And my denominator is always going to be my total. So what am I looking for in this case? I'm looking for number of blue and yellow cups next to each other. And I'm looking for my total on the bottom. Well, how many blues and yellow cups, how many blue and yellow combination cups did we have next to each other? 1, 2, 3, 4. All over how many in total? 1, 2, 3, 4, 5, 6. Well, 4 over 6 isn't an answer choice, which doesn't mean we did anything wrong. It just means we probably have to reduce. So what number goes into 4 and what number goes into 6? I can divide both numbers by 2 and get 2 over 3. Ooh, that. Winner, winner, chicken dinner. It is A for apple. Okay, remember, this problem didn't tell us specifically that we had to have yellow and then blue. But what if it did? What if it said yellow and blue in that order? Well, instead of having 4, we have a different amount because we want yellow first and then blue. So we look back at what we have and we have 1, 2. 2 of our combinations have yellow and then blue that are next to each other and in that exact order. So now we have 2 over 6. It is still reducible by 2 in the numerator and the denominator to give us 1/3. So it matters what the question says. You don't want to just fly through the problems and think that you understand it without really understanding the whole question, right? Because those words can mean the biggest thing, how to solve. And if you don't know how to solve, then you just messed up. Look at that. 1/3 is also an answer choice. All right, so take your time and read through your problems. Number 9. Number 9 is a trigonometry problem, so it's trig. And they're asking us to do what? So they're telling us that we have this function, and based on said function, which of the following statements are true? So we're looking for correct stuff. Well, in order to move forward, you need to know what the standard form of a trig function would look like. Just so happens to be something that I know. So the standard form of a trig function is f of x is equal to a times whatever your trig function is times b of x minus c plus d. Okay, so like, what does all that stuff mean? Well, let's start with A. A is your amplitude. Your amplitude is how high your wavelengths go, right? Think of amplitude as in like your amps, right? You're cranking up your amps, you're cranking down your amps. Then you have your B, which is your period. Oops, I spelled that wrong. You then have C, which is your phase shift. Another word for phase shift is going to end up being your horizontal shift. So that is how the parent function, the base function, moves from left to right. Right? And remember that when we have our phase shift, the sign is opposite of how it moves. So what do I mean by that? A positive number will move it to the left, and a negative number will actually move it to the right. I know, go figure. Because we're just looking at the number. So if you look at the sign in front, it tells you how to move it. Now D. What does D tell us? Well, we have how high something is going, how often it resets. We have our movement from left to right. So we only have one thing left. That's our vertical shift. Okay, so now we know all of the pieces to what we need to do. Let's start figuring it all out. Well, our amplitude is what? Our amplitude is 6. A is 6, B is 6, C is 6, D is 6. Oh, drats, that doesn't help us with anything because we still have all 4 answer choices. I'm going to skip the period and I'm going to go to the horizontal shift. Yeah, the horizontal shift. I'm not lying. So let's look at our horizontal shift. Here is our horizontal shift. What do we notice? We notice that it's pi over 2. Well, we're just looking for a number, right? So if we were looking for a number, pi over 2 is not getting us to that said number. So we have to figure out something else. Well, if I look at these, I have pi's, I have halves, and I have negative halves. Remember, we're just looking at the number, not the sign in front of it. So I can automatically say that the negative half is not what I'm looking for. I'm still looking for a number, and pi is not taking me to where I need to be. Pi is not going to be how I move from left to right. Our answer choice here is C. It's our winner, winner, chicken dinner, but how did I know that the period was going to be 2? So, little things that we should know. We should know that to solve for the period, we need to do 2 pi over b. Okay, well, when we plug in what we know, we have 2 pi over what? Remember, our number is the number in front of the x, and the number in front of the x here is going to be pi. Well, when I have pi over pi, that becomes 1, and I'm left with 2 as my period. They're not so bad once you know all the components to it. Okay, here is number 10. It's a probability and statistics problem, elementary and middle school level. So what do we know? We're given points and they're asked us to do what with it? They're asking us how far the points are from one another. Well, I can sit here and graph it. Let's try it. So I'm going to graph what I'm given. Here is my lovely graph. Now I'm going to put my points on there. Okay, well, there are my points. I'm going to now, not my points, there's my graph. Now I'm going to plot my points. Well, this one's going to be A and this one's going to be B. So I'm going to go to 4, 1, 2, 3, 4, and down 2. There's my A. Now let's plot my B. I'm going to go over to negative 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. There's my B. And they want to know what? They want to know how far the points are from one another. Well, plotting my points got me nowhere closer to solving my answer. So that's probably not going to help me at all. I can stare at this as much as I want to, but I'm not going to get anywhere closer to actually solving the problem. So let's try something else. Almost done. Let's look at our answer choices. I'm looking at my answer choices and I see what? I see this square root of 104. I see a whole number of 6. I see the square root of 72. I see the square root of 136. And I'm going, I still don't really know how to solve for how far something is. Well, let's restate the question. Instead of asking me how far the points are from one another, what if they asked me the distance of the points? Does that maybe make you feel a little bit better? Does that ring a bell? That should. I can use the distance formula of 2 points to solve for what I need. So let's start with what the formula is. The formula is the square root of what? x1 minus x2 squared plus y2 minus y1 squared. It's very important that you do not write the following: x to the first minus x to the second squared plus y to the second minus y to the first. Oh, I switched my numbers. I apologize. Keep it as y1 and 2. Okay. And then this one will become 1 and 2. Okay, 1 and 2 squared. This is the big fat no. Why is it the big fat no? We are not squaring or taking the first power of our points. We're saying that we have 2 x's and we're saying that we have 2 y's, and that said x and that said y will go into said places. But we are not squaring anything. If you're on a test and you accidentally write something to square, you're going to see it and you're probably going to end up squaring it. So now you're going to get a number that isn't correct, right? So you want to make sure that you're using your formulas properly and you're not rushing through them either. And as you can see, it's very easy to make a common mistake. Mistakes happen in math because it's human error. So before I actually plug in what I have, I need to name my points. So I already named them A and B, but what else do I need to do? I need to actually assign them x1 and y1, x2 and y2. So now here we can do either or. We can start with x1 and y1, or we can start with x2 and y2, as long as you're consistent. So remember, if I started with x2, I'm going to write it and erase it. If I started with x2, I would have y2. So then the other side would be x1 and y1. And it doesn't matter because I promise you, you will get the same answer. When we're finished, challenge me. Do it the other way and see what happens. Now let's plug in what we know. I know that x1 is 4, and I'm subtracting x2, which is negative 2. And I'm squaring all of that. I am then going to do my y's. I'm adding them. So my y1 is negative 2, and I'm subtracting negative 8. And I'm squaring all of it. I like to keep my second x's and y's in parentheses as long as they are not positive, because what now happens? These two negatives become a positive. So let's keep going. I will have 4 plus 2, which is 6 squared, plus, well, 8 minus 2, because my larger number is positive. 8 minus 2 is 6, and it's all squared. Okay, we're almost done. Keep your square root. Don't lose it. 6 squared is 36, plus 6 squared is 36. And 36 plus 36 is what? It's 72. Our answer here is C. Winner, winner, chicken dinner. But let's say that they didn't give it to you as the square root of 72. What if they asked you to write the square root of 72 simplified? Well, you start asking yourself, what numbers go into 72? Start with your lowest. I know that I will have 2 and 36. 2 times 36 is 72. What goes into 36? I will have 2 and 18. What goes into 18? I will have 2 and 9. And what goes into 9? 3 and 3. Well, that is a square root, so I'm looking for pairs. If they're not a pair, they can't come out. If you're not a couple, you're not leaving inside the square root. I have a pair of 2's here, and I have a pair of 3's here. So when they come out, they're now 1. So I'll have 2 times 3, the square root of what's left. So we're not looking at any of the numbers that we made smaller. We're only looking at the numbers that are as small as possible. The only guy we have left is, it's not a 2, it's a 3. Well, the best way you can write this out is 2 times 3 is 6, square root of 2. That is another way of saying square root of 72. All right, well, that's all I have for you guys today. But like always, I say a big thank you for showing up and a thank you for watching these videos. It's Math Wednesday, and if you ever need any help, we have one-to-one tutoring at the Learning Liaison. It is online tutoring, and you will go to the Learning Liaison's website and look for online tutoring or one-to-one tutoring. Aside from that, we have boot camps for all math levels and other subjects. You can get a discount code on the boot camp by remembering Sync 35. I make no promises of being here next week, but if you see me again, I hope you smile and you're not mad that Amy didn't show up. All right? Remember, she's off doing some pretty busy, big things. So maybe I'll see you guys next week. Maybe I won't. Have a great one. Bye-bye.